So in this video, I want to talk about water and mixtures. And so first let's define a mixture. And what a mixture is a solution, or like better, they are substances that are physically blended. But not chemically combined. But not chemically combined. And so what that means is you could recover each component. For example, if you have a mixture of salt water, you could easily evaporate the water and you'll be still left with the salt. And so most mixtures in our body consist of chemicals dissolved in water. And water is known as a universal solvent, and water is actually accounts for 50 to 75% of our weight. And so water is a polar molecule, forms hydrogen bonds, and it has a bunch of properties that account for its ability to support life. So solvency, cohesion, adhesion, chemical reactivity, and thermal stability. And so let's talk about each of those. So solvency, first, is the ability to dissolve other chemicals. And water is the universal solvent. Which means that it's essentially pretty much it'll dissolve anything. But there are two types of substances, hydrophilic and hydrophobic. Thus, the universal solvent isn't too accurate because water can't dissolve hydrophobic substances. So for example, if you put oil in water, like if you ever have a salad dressing, you'll see that there are different layers and they're not completely dissolved. The other one is hydrophilic, and those that will dissolve in water. And then cohesion is the tendency of molecules to stick together. So water molecules are very cohesive due to the hydrogen bonding, and they will stick together very well. And then an example of that is surface tension. And adhesion is the tendency to stick to other things. And then finally, thermostability. What that means is it's essentially water has a high heat capacity. So it means that water can absorb lots of heat before actually heating up. And so it can absorb a lot of energy without changing temperature, and this makes it very good because when you sweat, you get rid of water, and if water evaporates, it can take away a lot of heat. And so if you compare water to metals, they're going to be very different. Metals have a low heat capacity. If you ever leave, for example, get into a hot car, like leave your car out in the summer, and you touch the seat belt, it's going to be really, really hot. While if you leave a water bottle in the car, it won't be as hot. And so now let's get back to mixtures in water. So there are three types of mixtures. There are solutions, there are colloids, and finally there are suspensions. So first, a solution is unique in that solute particles will pass. So solute passes through most selectively permeable membranes. And so when the solution stands, so for example, when you're not mixing it anymore, the solute does not separate. So it doesn't essentially sink to the bottom. And so, oh, one thing I forgot to mention, a solution, any solution, a solute is the one that there is less of, and the more abundant substance is called the solvent. It's usually water. And so now let's talk about colloids. So colloids, the solute is essentially, there are larger particles. An example is albumin. And so with colloids, the solute also does not separate from the solvent. Also, another example is Jello. Jello is a colloid. So essentially think of the consistency of Jello. And an example of a solution back here, we'll just give salt water. And so the solute kind of varies here, whether it can pass through most selectively permeable membranes. And so it's not like some of it will, some of it won't. It's not too clear. Now let's move on to suspensions. A suspension has large particles, so very large particles. And then so they're too large, so solute does not pass through selectively permeable membranes. And the solute will separate. It will separate when it stands. And an example of that is red blood cells. Red blood cells in your blood. Very big, won't pass through selectively permeable membranes. And so your blood actually has many things. So the red blood cells are suspensions in your blood, proteins in your blood are colloids, and ions in your blood are solutions. And so what we can take away from that is there may be mixtures that consist, there may be things that consist of more than one mixture, for example, blood.